Okay, we're here. We're going to take two. I just didn't like the last video on Louis de Broglie. Louis de Broglie was a French physicist. He was born in 1892. He died in 1987. I remember when he died. I was teaching physics when he died. Amazing. I remember when he died. We talked about it in class. We talked about his life. Amazing. And he was big on considering electrons as what?
Waves.
As waves under certain
Conditions.
under certain conditions. Prior to, this was 1924, right?
Yeah.
So in 1924, he postulated that light can be considered a wave. Matter of fact, everybody thought he was a little nutty. They sent his work off to Albert Einstein, among others, and they said, good idea, really good idea. Einstein became a little bit uncomfortable with the idea after he thought about it for a while, but again, like I said in the first take of this video, is they create experiments. They excite the environment. The environment responds. We take that response as data, and we collect data. Then we have data. So then we build a model that's consistent with that data. We build a model that an electron is a wave, and that model is consistent with other experiments on light. However, it's inconsistent with others. So we have that other model which says they are particles. Electrons are particles. So he came up with, it was really de Broglie that I think originated this, the wave, what's it called? Wave particle duality of nature. That under certain circumstances, under certain conditions, the electron can be thought of as a particle, and under other conditions it could be thought of as a wave. Easy? What else did de Broglie come up with? Anything else?
Yes.
All right, what do we got?
He helped scientists understand that the atom didn't behave like a solar system because electrons do not move in regular orbits.
Help scientists, let's call it the science community. He helped scientists understand what?
That atoms don't behave like solar systems because electrons do not move in regular orbits.
He said that the atoms, the planetary model of an atom, where the electrons are planets revolving around the sun, revolving around a central nucleus, is not a good way to demonstrate the nature of an atom. That electrons
do not have regular orbits.
They don't have regular orbits. Well, they have regular orbits in a sense, but they're not like planetary. In other words, they have regular, let's not say orbits, they have regular energy levels. They have predictable energies. Yes, we're going to talk about that, SPDF, we're going to talk about quantum numbers, we're going to talk about the principal quantum number, the shape quantum number, etc. But just leave it to be that the planetary model is not good. And in the next chapter, we're going to talk about the distribution of electrons around the nucleus, and that it's very complex. Very complex. It's not as simple as Bohr or Nagaoka first seen. But the planetary model is good because it does explain some of the nature. So it's a great starting point, isn't it? It's a great starting point for understanding. When I teach 7th graders, I'll teach them the planetary model because it's easy to understand. And when they get to your level, then you can bring in a little bit more complicated information relative to sublevels, suborbitals, SPDF, quantum numbers, etc. What else? Anything else about de Broglie? Are we finished with de Broglie pretty much? Yes.
He developed like ideas in wave mechanics, and he helped scientists like Erwin Schrödinger in wave mechanics.
Okay, so let's just say wave mechanics. Okay, wave mechanics. Okay, now there's somebody called, we're going to introduce the next guy, but we're not doing it today. We'll do it our next class. Okay, what time is it? What time do we have until?
You have 10 minutes.
10 minutes? Okay. I want to erase this, is that okay? Okay. Now I need you to help me spell. Okay. I'm going to introduce the next scientist to you. And the reason I'm doing it now is because, according to Ishmael, that he helped this particular scientist with his development of wave mechanics. Okay? Wave mechanics. Wave meaning the electron. Okay? Genevieve's surfing. Okay, the wave mechanics, right? And what was that scientist's name?
Erwin Schrödinger.
How do you spell the last name?
S-C-H-R-O with 2 dots on top of it. D-I-N-G-E-R.
And what was his first name?
Erwin.
Erwin. You spell Erwin, that's a German name, huh?
Yeah, E-R-W-I-N.
Erwin Schrödinger. Now, Erwin Schrödinger is very famous for coming up with something called...
Cats thing.
He was Austrian.
Cats!
It's a German name, but he was Austrian.
He was Austrian. Yeah, German, Austrian. Very different countries, of course. I don't mean to insult the Schrödinger family by calling them German if they feel that way. Austrian, they were Austrian. However, he's famous for coming up with... Genevieve was talking about cats. What's cats mean? What does that mean?
Schrodinger's cat.
Yeah.
Schrodinger's cat? Okay.
An experiment.
An experiment. Very good.